Hello and welcome to our quick mini lesson on probability distribution, expected value when there is a payment involved. So this could be a warranty situation, a life insurance situation, a game of chance where there is a payment. And what we're going to do for our table on this is to help us visualize what's happening and to make our mathematics easier. We want to set up our table just a little bit differently, and we're going to set it up in a timeline fashion. The fact that every insurance that you would purchase, every game that you have to play, you pay up front for that. So let's look at a nice easy situation. Okay, you are going to pay $100 for iPad insurance. Okay, so we know that in this situation, you pay that $100, you lose that money 100% of the time. You have to pay for the game, or you have to pay for the insurance, or nothing else happens after that. And then what happens is we just have two outcomes. What happens if it breaks, not beaks? Let's fix that real quick. What happens if it breaks? And what happens if it does not? Now, if this is like a casino game, it would just be what happens if you win and what happens if you lose. So now, for this iPad insurance situation, if the iPad breaks, you have saved yourself the amount of money of buying a new iPad. And then they assign some probability of that. Okay, there's a 2% chance of that iPad breaking. Okay, now, if it doesn't break, or if you lose the game, do you get anything at that point? No. So your value is 0. Now we need to finish out the probability, 0.98. But now notice in this situation how much easier your math is to complete this problem for an expected value. Okay, so once again, it's based on a timeline situation. You pay for it first, and then time starts ticking from there. And then the next thing we look at is, do you win, or does something break so you're using that insurance to gain yourself some money? And then we continue on, and what happens if you lose, or what happens if it doesn't break? So now when we look at the expected value of this situation, the mathematics are very nice and clean. So we have 100 times 1 plus 500 times 0.02 plus, and then we have 0 times 0.98. Well, what happens is that one's naturally 0. This one's automatically 100. So all we really need to do is finish up the 500 times 0.2, okay, and we get 100. Okay, so what we've actually found here is we found a perfect break-even scenario. The amount that you pay is equivalent to the proportional amount that you save yourself when it breaks. But this is a great way to set up expected value problems for insurance or for games of chance with a payment, to identify it in a timeline fashion and to make your work very quick and easy mathematically to finish it up. Thank you and have a good day.